Hi, and welcome to the remainder of section 2.3. You've watched the intro video, gone through some of the shortcut formulas with Dr. Taylor, so we're going to continue and work on the rest of the notes and hopefully get you guys on the right path to using these shortcut formulas the right way. So again, on the front page are all of your basic functions and formulas on how to find derivatives. So what I want to talk to you about is the note at the bottom. It does tell you, and this is real important, that if you have a function or two functions being multiplied, then you cannot just take the derivative of each of those functions, and the same goes for division. Okay, so if you notice in the properties in our formulas, we have the rule that yes, if you're adding two functions, you can take just the derivative of those two functions. And if you're subtracting, you can do that. Okay, but please remember, you cannot do that for multiplying or dividing. Okay, so for today, I wrote this out if you want to write it or read it. But for today, if you have a multiplication or division problem, you must simplify it first so that you reduce down to individual terms. Once you reduce down to individual terms, then you're looking at these last two, and that's fine, okay? So always we want to simplify first on a multiplication or division problem, get it down to an individual terms, and then go from there. The other thing about that is all your variables, okay? All your variables when you work these shortcut problems must be in the numerator, and you must write all your variables with rational exponents. So I just did two quick examples here. So for example, if you have a variable in the denominator, you would write that as x to the negative 2. Okay? Again, this is a division problem and we don't have a rule for division. So we're going to write it this way so we can do the rule. And then radicals, we don't have a rule for this. So we're going to rewrite it as x to the 3/2 so that we do have an exponent and we can use that power rule. Okay? All right. So those are kind of the important things. So some of you guys that have taken calculus before and know the product and quotient rules, it's fine if you do it, but those of you who do not know it, then this is kind of what we're doing right now. Because in section 2.4, we will learn how to do that, okay, without having to simplify first. Okay, so back up on the rules, just want to be very clear about constants. Okay? Remember that when you take the derivative of any constant, it is 0. And remember that pi is a constant, okay? A lot of problems will put pi in it, and you guys kind of think that's a variable. So it is not. Pi is a constant, so the derivative of pi is 0, okay? All right, and then the other thing I want to remind you of is, the basic rule, this is called a power rule. When you have a variable raised to a power, you bring the exponent out front, and then you subtract 1 from the exponent. And I know Dr. Taylor did a bunch of those with you. But keep in mind, if there's a number out front, a constant, okay, then you're simply taking that exponent, still bringing it out front, so you would end up multiplying it by the constant. And then you still subtract 1 from the exponent. All right, so let's kind of go through. We're going to pick up on number 12. Before we do that, on the next page, I just wanted to mention to you at the bottom of page 46, these common derivatives. Not a big deal if you don't know them, but obviously the more and more we do it, you're going to get tired of doing the work. So these two come up quite a bit. So if you're doing the square root of x, it's always good to remember that that derivative is 1 over 2 square root of x, because obviously if we're doing the square root of x, we would write it as x to the 1/2. Derivative of that, bring the 1/2 out front, and then subtract 1. Well, any exponent raised to a negative power goes in the denominator, and negative 1/2 or to the 1/2 power means the same thing as square root. So it's good to kind of know that. Now it's fine to leave things like this. I'll say this a lot over the videos, that when you're just finding a derivative, you can leave it like that. But if you're going to work with the derivative and plug in numbers, then you'd want to simplify it, right? So in this class, we're fine with you not simplifying. That's okay. WebWorks will take it. I'll take it. But you need to be able to simplify for two reasons. Again, one is if you're going to use it and plug in numbers, okay? And the other reason would be if it's a multiple choice question, you need to be able to find the answer no matter how it's given to you, right? So just because you didn't simplify it doesn't mean on that multiple choice test it may or may not be simplified. So leave it like this unless you need it. WebWorks will take it like this, but know that you have to be able to simplify it down to what it would look like, you know, when you're done reducing it. All right, and then the other one is the 1 over x. We know the derivative of that is negative 1 over x squared. Again, just using the properties from the front page, we get negative x to the negative 2 power, which is just putting the x squared in the bottom. Okay? All right. Last thing, I'm just trying to remember things to tell you guys, but the last thing is the trig functions. You do have to learn those. Those are just the derivatives. So you need to know that the derivative of the sine of x is cosine of x and so forth. I put little marks by these three, and notice you can kind of see the commonality, or at least this is how I remember learning them, that any derivative, any trig function that starts with the letter C, so cosine, cosecant, and cotangent, notice that those are the derivative functions that are negative. Okay, now you still got to learn what goes with it, but in my head, I remember when I first learned these, I always knew if I found the derivative of cosine, cosecant, or cotangent, my derivative had to be a negative value. Okay, so that's just kind of a little trick to help you to know which ones are positive, which ones are negative. Okay, all right, so I think I've said all I want to about those front pages. So we're going to start with number 12. We're going to just go through a few more problems and find these derivatives. All right, so on number 12, first one we're starting with today is a division problem. So again, I don't have a rule for division, so I would have to simplify. And to simplify a division problem, you're basically just dividing the denominator into each numerator. Okay, so that's what we're going to do. So we're going to divide x cubed by x, which would give me x squared. And then I would divide 4x squared by x, which gives me 4x. Okay. So now I've taken the division problem, I've simplified it, now I have two terms, so now I can find the derivative of this. This is what we're doing today. So p prime of x. Okay, so this is power rule, so we're going to bring the exponent out front and subtract 1 from 2, which is 1. So bring the exponent out front, and 2 minus 1 is 1. We don't need to put a 1 there, so 2x is the derivative of x squared. Okay, and then the rule for a linear term, 4x, the derivative of any linear term is just the constant, so just 4. Okay, so there's your derivative. All right, number 13. Again, I've got a product here, x plus 3 times x plus 3. I don't know any rule for this, so I'm going to have to multiply that out. So that's just a FOIL problem. So if you FOIL, right, x plus 3x plus 3, that's what we're doing. That would give you x squared plus 6x plus 9. So again, today we need individual terms. So now we can take the derivative of those three terms. Okay, so we just did x squared. The derivative of x squared is 2x. The derivative of any linear term is the constant, and the derivative of any constant is 0. So there's your derivative. Okay, 14 are just trig functions, so you just need to know the rules. Okay, nothing special here. So the derivative of the sine of x is the cosine of x. And by the way, when you put these in WebWorks, all arguments, that's the variable, has to be in parentheses. So we write it this way on paper, but in WebWorks, you must put parentheses around your variable terms because otherwise it won't know what to do with it. So make sure you do that. And then the same thing here. I'm going to show you. So the derivative of tangent of x is secant squared. Okay. Now, we write secant squared on paper, but on a computer or your calculator or WebWorks, whatever, you would have an error message if you wrote a word squared, because your computer doesn't understand that, and neither does your calculator. So on WebWorks or on your calculator, okay, if you were computing this, you would have to write f prime of x is cosine of x, that one's fine, this is how secant squared x would go in your calculator. You would have to put parentheses. You would write the secant of x, close your parentheses, and square that. So this is just the shortcut way, because remember, you're not squaring a word. You're going to take the secant of x and then square it. That's what this means. So this is the mathematical calculator way to put in a trig function that you're squaring. Okay, so pay attention to that on your calculator, also in WebWorks. And it's real important. All right, number 15. So this is okay on paper. Okay, just I want you to make sure you understand the difference in that. This just prevents us from making more parentheses. This basically was created for textbooks so that we wouldn't use a lot of ink and the textbook companies would save space. So that's kind of how that came to be. All right, number 15, g prime. Okay, remember when you have a constant times a function, the derivative, you're going to keep the constant and then just take the derivative of the function. So 2 times, and now the derivative of cosine is negative sine of x. And then plus the derivative of secant is secant tangent. Okay. And again, I would, you could put that into WebWorks just like that. If you were doing that problem, I would mark this correct. If you want to simplify it, then you would end up with negative 2 sine of x. Right? And that's fine. They're all correct answers. Nice thing about finding the derivative is you do not have to simplify it unless you need to, okay? Unless you're asked to, or again, you're using it in a problem. All right, so I'm okay with this. That's first step, always works. All right, number 16, we got to do a little simplifying because we don't know how to find the derivative using a radical, so we're going to write that using a rational exponent. So f of x, instead of doing the cube root of x, would be x to the 1/3 minus the cotangent of x. Right? That's what we're going to find the derivative of. So f prime of x. So we're going to use the power rule, bring the 1/3 out front. And then we're going to subtract 1 from 1/3. So 1/3 minus 1 is negative 2/3. Minus, now I'm going to do this the way this problem says. So minus, and now I'm going to find the derivative of cotangent. Okay, well the derivative of cotangent is negative cosecant squared. Okay. So you can leave it like that, or you can change that to plus. It doesn't matter. As long as you can tell which one is which and that they're both the same, that is fine. Okay, so either one of those would be fine. There's your derivative. All right, number 17. We're going to find the derivative and then find the derivative at 2. And then on the next page is continued to number 17. They should be on the same page, but we're going to still be using this function. Okay. All right, so this is just a polynomial, so we can take the derivative straight from here. First term, bring the exponent out front and subtract 1 would give you 3x squared. On the second part, we're going to bring the exponent out front and multiply it by the constant that's already there, so that'll give you 8x to the first power, so that's just 8x. Linear term, the derivative is just the constant, and then a constant term, the derivative is 0. So here's your derivative, and now we're asked to find the derivative at 2. So remember, this is a cubic function. The derivative is how we're going to find the slope at any given point on this function. So now I'm asking you to find the slope value when x is 2. So I'm going to plug 2 into the derivative. Okay, so that would be 3 times 2 squared plus 8 times 2 minus 2. So we're just going to work that out. So 3 times 2 squared, that's 3 times 4. Remember your order of operations, plus 16 minus 2. So that's 12 plus 16 minus 2, which will give you 26. So that is the slope. So that's a very, very steep line. Okay, remember, 26, so the very steep line that goes, it's almost vertical if it has that high of a slope value. All right, so on the next page, this is a continuation of 17, so I went ahead and wrote the derivative down in the function above there so we can continue. So now the second part of number 17 asks you to find the second derivative of x. Okay, notice there's two little tick marks, so that's a second derivative, which means you're just finding the derivative of the first derivative. So now we're going to find the derivative of 3x squared plus 8x minus 2. So again, the first term, take the derivative of that, bring the 2 out front, multiply it by the constant that's already there, which gives you 6x. That's your linear term, so the derivative is 8. And that's the constant term, so the derivative is 0. So here's your second derivative, and now we're going to find the second derivative at 2. This tells us some other things that we'll learn about later. Okay, so we're going to plug in 2 into the second derivative, 6 times 2 plus 8. So that's 12 plus 8, so that gives you 20. Okay, so when you're finding derivatives at numbers, you're going to get a numerical value. If you're just finding the function derivative, then it's a function. All right, number 18, got to clean this up a little bit because we can't do a division problem. So the first thing I'm going to do with 18 is write the square root of t as t to the 1/2, so you can kind of follow along. So that's the square root of t in the bottom is t to the 1/2. So I'm going to have to divide t to the 1/2 into each of these numerators. So if I have a variable, I'm going to subtract my exponents. And on this last term, I'm just going to bring that up to the top by making that a negative exponent. Okay? And remember, t is t to the first power. All right, so we're going to just subtract. So we're going to do 4t squared divided by t to the 1/2. That gives you 4. And then 2 minus 1/2, okay, 2 minus 1/2 is 3/2, so that's 4t to the 3/2. Plus, now we have t divided by t to the 1/2, so we're going to subtract 1 minus 1/2, that gives you 1/2. Plus, and then since there's no division here with the t's, I'm just going to bring that t up and make it a negative exponent. Right? That's how I simplify it. So now this is what I can take the derivative of using my power rules. Okay, so g prime of t. So we're going to multiply 3/2 times 4. Okay, 3/2 times 4, that's 12/2, which is 6. So that would be 6t, and then you're going to subtract 1 from 3/2. If you subtract 1 from 3/2, that gives you 1/2. Plus, this one has no constant, so we're just bringing the 1/2 out front. We're subtracting 1 from 1/2, so 1/2 minus 1 is negative 1/2. So there's that derivative. And over here, we're going to bring this and multiply it. So negative 1/2 times 5 is negative 5/2. And then subtract 1 from negative 1/2, that gives you negative 3/2. So there's your derivative, 6t to the 1/2 plus 1/2 t to the negative 1/2 minus 5/2 t to the negative 3/2. All right, so now we're asked to find g prime of 1. So that looks kind of daunting, but 1 to any power is 1, so that's kind of nice. So we would do 6, 1 to the 1/2 plus 1/2, 1 to the negative 1/2 minus 5/2, 1 to the negative 3/2. Okay? All right, so remember, 1 raised to any power is 1. So we're just going to end up with 6 plus 1/2 minus 5/2. Okay, so you can do that in your calculator, however you want to do that. This would be 12/2 if I got a common denominator. So 12 plus 1 is 13 minus 5, so I should end up with 8/2, which is 4. And it's fine to work that on your calculator if you're not a fraction person. Okay, so now the fun begins. We got to find the second derivative. So we're going to find the derivative of this, okay? So just be careful with your signs. So we're going to take the 1/2, multiply it by 6. That gives me 3. Subtract 1 from 1/2. That gives me negative 1/2. All right. Now we're going to take negative 1/2 times 1/2. So that's going to make that a minus 1/4 t. And then subtract 1 from negative 1/2. That gives you negative 3/2. And then we got negative 3/2 times negative 5/2. Okay, so it's going to turn into a positive number, 15/4 t, and then subtract 1 from negative 3/2, that gives you negative 5/2. So the rules are the same. You know, fractions are a little bit harder to work with, but you need to be able to subtract. So don't let not being able to work with fractions stop you. Just use your calculators, okay? All right, and again, the good news over here on the right is we're finding g double prime of 1. So we're going to substitute in 1. That 1 to any power is 1, so that helps us with this. Okay, so just substitute in 1 in there. Okay, so again, 1 to raise to any power is 1. So this is just 3 minus 1/4 plus 15/4. Okay, so 12 over 4 would be 3. So 12 minus 1 is 11. 11 plus 15 is 26. So we should end up with 26 over 4. You could leave that. You could reduce it. You can write it as a decimal, however you want to write it. WebWorks would take if this is a WebWorks problem. And if it's just on the test, you could enter it like this. Again, if it's multiple choice, you need to be able to find the right answer. Okay? All right, number 19. Kind of fun, I guess. This is just so that you practice with derivatives. So it says find the first 6 derivatives of this function. Okay, and some of this is about notation as well. All right, so let's find the first derivative, h prime of x. I'm just going to do these underneath each other. Take power rule for each of these. So bring the 5 out front, subtract 1 would give you 5x to the 4th. 4, we're going to multiply it by negative 2, so that's negative 8x cubed when we subtract 1 from that. Okay, next term, 3 times 3 is 9. Subtract 1 from your exponent, squared. Linear term, so derivative of that is just 1. And constant term, derivative is 0. So there's your first derivative. All right, now we're going to take the second derivative. Okay, so derivative of the first term, 4 times 5 is 20. Subtract 1, so 20x cubed. 3 times negative 8 is negative 24. Subtract 1 for your exponent, you get negative 24x squared. 2 times 9, 18. Subtract 1. And then that's your constant term, so there's your second derivative. Okay, all right, third derivative. 3 times 20, 60. Subtract 1 from your exponent, so 60x squared. 2 times negative 24, negative 48. Subtract 1 would give you negative 48x. Linear term, derivative is 18. So there's your third derivative. And this is a good example for when we're looking at those graphs. You know, always know your derivative is always 1 degree less than the problem. So that helps with the graphing and picking out graphs, right? So keep that in mind with polynomials. All right, fourth derivative. So here's the thing. Once we start getting into third, fourth, fifth, sixth derivative, how many tick marks can you possibly write? So instead of doing h 1, 2, 3, 4 of x, okay, that you're going to sometimes see it like this. It's kind of just a shortcut way. So this is just a fourth derivative, but you wouldn't start, like you wouldn't put a 1 there or 2 there. Okay, typically once we get to fourth derivatives and higher, you can start doing that. So it's fine, but just so that you know, this is the correct way, obviously. But if I asked you to find the 20th derivative, you're not going to write 20 little tick marks. So we understand that when you're doing a process like that, that's an okay shortcut to write. So 2 times 60 is 120. Subtract 1 would give you 120x. And then there's your linear term, so just minus 48. And lastly, the fifth derivative, linear term, 120. Okay? All right, so just being able to take derivatives using the notation, just making sure all that is good. All right. So hopefully you're enjoying these shortcuts instead of doing the limit definition, formal definition. Just imagine how long all of these would take us if we had to do them all that way. So these shortcuts are really nice, and that's what we'll be using from here on out. Okay, so you gotta get these down because Everything we do is going to revolve around all these rules we're learning this week and next week with derivatives. All right, so part B, now we're going to kind of look at a couple applications with these derivatives. So we're going to start with normal and tangent lines. Now you guys already know what a tangent line is to a function. A tangent line is a line that touches a curve at a specific value, right? It just touches at the curve, tangent line. And now we're going to bring into this what we call normal lines. Well, a normal line would be perpendicular to any tangent line at any given point. So if I changed my point up here, then the tangent line would be here, and then the normal line would be perpendicular to that tangent line. So they have to give you a value or ask, tell you where you're finding these lines so you know what points to use. Okay? All right, so if you look at number 20, find the horizontal tangent lines. Lines that have a slope of 0. Remember what that means. A horizontal tangent line, okay, has a slope of 0 to this function. Okay? So here's where I would, if you know your rules for polynomials, you remember these from algebra or your trig class for calculus, okay? I know that this function starts down here, ends up here to the right, the end behaviors, and I know the y-intercept is 23. I don't know much else about it unless I put my calculator, and I don't really want to put it in my calculator, I just want to kind of sketch it. So let's say it looks something like that. Okay, that's just a very rough sketch. So, this could be 23. Well, it is 23. So where are the horizontal tangent lines? So remember, horizontal tangent lines are max and mins. So here's the horizontal tangent line, and right here. Now, here's the thing. Find the horizontal tangent line. So if you're writing an equation of a horizontal line, think about it. The equation of any horizontal line is y equals and then whatever the value is, right? So that's what I'm trying to figure out. What are the y values here? So do I need calculus for this? No, not if I have a calculator, but I want to show you how to do this using the calculus. So to find the horizontal line, if the slope is 0, that means I can set the derivative equal to 0. Okay, that's what that says. So if I find the derivative of this function, okay, use your rules. So 3 times 2, 6x squared, plus 2 times 3, 6x, and then the linear term. So there's your derivative. So if I set the derivative equal to 0, what is that saying? Okay, if I set this equal to 0, that is saying that I'm going to find the x values where the slope is equal to 0. And if I'm going to find the x values where the slope is equal to 0, okay, the x values, then I can easily then plug those numbers into my formula and find the y value. That's what I need. Okay? So this is easy to solve. We're going to factor out a 6 from all the terms. We're going to factor. So that would be plus 5 minus 4. Get our two values. Now remember, that's not an x term, so you don't set, that's not one of your roots. You just set roots that have variables in them equal to 0 and solve. So there's 2 places where we have a tangent line equal to 0. The slope is equal to 0. 4 and negative 5. Okay? So now I know this is negative 5 and this is 4. Those are the x values. But I'm supposed to find the equation of the horizontal tangent lines. So that is the y values. Okay, well, once I know x, and this is real important, whenever you are looking for a y value on the original function, you're going to plug these numbers into the original function. So again, you can use your calculator, you can go to the table, okay, but we need to find f of negative 5 and we need to find f of 4. That's what we got to do. And we're plugging those numbers not into the derivative. If you plug those into the derivative, you're going to get 0. Okay, we already know that. What I want to know is what are the values of these points? What's the ordered pairs? So I'm going to plug negative 5 into the original function. 2 times negative 5 cubed plus 3 times negative 5 squared minus 120 times negative 5 plus 23. Okay? I would use your calculator. Obviously, I don't want to spend time plugging all that in, so just plug that in just like that into your calculator. That will give you a positive 448. Excuse me. And then we're going to plug 4 in, so 2 times 4 cubed plus 3 times 4 squared minus 120 times 4 plus 23. Get that y value off of your calculator. That would give you negative 281. Okay. You can pause and work that, make sure. So now I know this ordered pair is the ordered pair negative 5, 448. And this ordered pair is 4, negative 281. So finally, I can answer the question, what are the horizontal tangent lines? So the horizontal tangent lines would be y equals 448 and y equals negative 281. Those are equations of horizontal lines, okay? So again, if you look at this and you say, why can't I just graph it and find the max and mins? Well, sure, you can. But remember, a lot of these problems are on non-calculator parts and you're not supposed to have a calculator, so this is how I would have to find it, okay? So some things you don't need the calculus for, but it is neat how that works, okay? So we can do it without graphing anything. We don't need to see the graph. All right, let's look at number 21. The same kind of problem except a trig function. So you guys got to be good at doing the trig functions and remembering your values. All right, now this one we add, not only do we have to find the tangent line, but also the equation of the normal line. Remember, that's perpendicular. Okay? All right, so let's just think about this function first off. Again, knowing this is very helpful to you because that's kind of what I need to be able to do. So, that's a very basic function, okay? Cosine of x, you should know what that looks like. And then putting the 4 out front, that's the amplitude. So that just means it's going to go up to 4 and down to negative 4 instead of going from 1 to negative 1, okay? And the cosine, I'm just going to plug in our basic values, pi over 2, pi, 3 pi over 2, 2 pi. So cosine graphs always start up at 0, so that would be here. Then it comes to 0, and then by pi we're down to negative 4, and then we start back up to where we started. So that graph, do you have to know this to do this problem? No, but I just want you to visualize because some of you like to see what the heck we're doing. Okay, now this one I can't really do on my calculator because there's some crazy numbers involved here. So pi over 3. Where is pi over 3? So I want the tangent line and the normal line to this function at x equals pi over 3. Well, pi over 3 is a little smaller than pi over 2, so I'm just going to put pi over 3 here. So let's say there's the ordered pair. So the first thing I need to know is the ordered pair. Okay, what is the ordered pair? What is the point? Right, pi over 3 what? That's my first thing. I need that ordered pair to write the right. I need x2 minus x1, so I need those points. So we're going to plug pi over 3 into the function. So we're going to find f of pi over 3. So we're going to plug pi over 3 into here. 4 times the cosine of pi over 3. Okay. Well, what is the cosine of pi over 3? Well, the cosine of pi over 3 is 1/2. You should know that. And 4 times 1/2 is 2. So the ordered pair on the graph, okay, the point is pi over 3, 2. Okay, so now I know my ordered pair. Because remember, to write the equation of lines, we need this formula, right? Remember what we're doing. Okay. So I needed the point because I'm going to have to plug those numbers into here, x1, y1. Now what do I need? I need the slope. Well, how do I find the slope at this point? That's a derivative. Now, look at this line, the tangent line right here. The tangent line would be right about there, right? Tangent line. So automatically, what kind of slope should I get? I should get a negative number. That slope, that line is going down. So the slope of this line, the derivative of this line, which is the slope, should be a negative number. Okay. So again, I'm just in my head, I like to kind of know what I'm doing ahead of time so that I can kind of make sure that I'm on the right path as I'm working it. All right, so to find the slope, we need the derivative. Remember, derivative is the slope, okay? So first I'm going to find the derivative function, and then from there I'm going to find the derivative at pi over 3. I need the number. Okay. So first I have to find the derivative function. I'm going to do the derivative of this, and then we're going to plug pi over 3 into that. So I have a lot of students, they're very confused. How do I know whether to plug pi over 3 into the original function? How do I know when to plug pi over 3 into the derivative? So remember, you are finding an ordered pair. That's the original function. You want to know where that point is on the function. When you're plugging the number into a derivative, that's giving you the slope. That's it. So you'd only plug pi over 3 into the derivative if you want the slope, and we need the slope. So that's what we're getting ready to do. All right, so let's do the derivative of 4 cosine of x. Okay, so there's the constant. We're going to leave it. And then what is the derivative of cosine? Remember, that's a C word, so it's going to be negative sine of x. And since I'm going to be using this, I'm going to go ahead and simplify it to negative 4 sine of x. Okay, so there's your derivative function. So now to find the slope of pi over 3, I need the slope of this line. I'm going to plug pi over 3 into here. So negative 4 times the sine of pi over 3. Okay, well, again, you guys need to know your unit circle. So what is the sine of pi over 3? Okay, that is the square root of 3 over 2. We're going to multiply that. So that gives us negative 4 square root of 3 over 2. And then that can be reduced to negative 2 square root of 3. Okay. So I'm going to put m over here. So there's our slope. Look, it was negative. That's what I said it had to be. So this is just a decimal number. I'm just going to leave it as radical. Again, if you're using WebWorks, if you're going to take the square root of 3 and get the decimal value, remember that WebWorks will not like it if you round. So you need to put at least 6, 7 digits after the decimal point if you're going to use a decimal. And also, as you work a problem, if you are rounding inside the problem, then when you get to your final answer, it will be wrong on WebWorks. So you cannot round until everything is done. Okay, so I just always suggest leave radicals as radicals, leave fractions as fractions, because if you guys start rounding those decimals too soon, you're going to get the wrong answer and get frustrated on WebWorks. So keep that in mind, okay? All right, so I have to do 2 things. I'm going to write the equation of the tangent line and then the normal line. So I'm going to draw a little line here to separate our paper. So the tangent line, let's get our information. Okay, for the tangent line, we're going to use the point pi over 3, 2. And we're going to use the slope, negative 2 square root of 3. That is the information for the tangent line. All right, then I'm going to have to redo my problem and do the normal line. The normal line is this line, one that's perpendicular to the tangent line. So, same point, right? Same point, but how do I find the slope of a line perpendicular? Remember, it's the negative reciprocal of this. So if the slope of the tangent line is negative 2 square root of 3, then the slope of the perpendicular line would be positive 1 over 2 square root of 3, right? Okay. So we're going to now do exactly the same thing. We're going to use this formula. We're going to get this equation of the line, and then we're going to do the same thing over here. So the only difference is your slope. So normal lines is just a fancy way to say perpendicular. So you have all the information now. All right, so for the tangent line, y minus 2 equals negative 2 square root of 3, x minus pi over 3. Now, just so you guys know, don't panic, because if you're typing this in WebWorks or you're typing this for me, all you have to do is solve for y. So if I want to solve for y, I would just move the y to the end of the other side, so plus 2. WebWorks will take that. That is your equation of the tangent line, okay? If this was a multiple choice question and it was multiplied out, then sure, you could multiply the 2 squared of 3 times everything. But I'm telling you, this is fine for an answer, okay? Now, I'm going to go ahead and multiply this out just to see what happens, just to help you guys. So, negative 2 squared root of 3 times x is negative 2 squared root of 3x. You got a negative number times a negative number, so that's going to be positive. This is in the numerator, so this would be 2 pi squared root of 3. I always put the radical at the end, because if I put pi over here, sometimes it looks like it's under the radical, and it is not. But you could write 2 squared root of 3 pi, okay, over 3. And then negative, oh, and then I'm not multiplying, that's not part of it, so there. So that's what it would look like multiplied out. So here's what I was saying right there. Some of you say, why don't I put the pi at the end? So if you did this, that's fine. But what I'm saying is some of you write this and you do this. So it kind of looks like the pi's under the radical, which it's not. So it doesn't matter where you put the numbers. Just be careful with this, the symbol, okay? All right, so that's distributed out, but you don't have to do that. So that's good news for what's coming up next, because we got a fraction here. So now if we do the normal line, we would do y minus 2 equals, and this time we're going to use the perpendicular slope. It's minus pi over 3. Okay, so again, solve it, move the 2 over. So this is perfectly okay as your answer. WebWorks would like it. Just watch your parentheses. Okay. And look, you know, the normal line has to have a positive slope, right? So going up. So that would make sense that it's positive. So that is fine. Leave it like that. If you multiplied it through, let's look at what that would look like. This would be 1 over 2 squared root of 3 times x would be x over 2 squared root of 3 minus, and then 1 times pi, pi would be in the top. And in the bottom, you multiply your numbers. So 2 times 3 is 6 squared root of 3 plus 2. So if you wanted to multiply it out, that's what it would look like. Okay? All right, so we're going to do part C next, but I'm going to go ahead and stop the video here and just start another one in case you want to start working on your homework or go back and look at anything. So we'll do another video to pick up from the rest of the notes for section 2-3. Okay, let me know if you guys have any questions.